All right, this is a section 5 from Unit 3 on proving triangles congruent using angle, side, angle, and angle, angle, side. So the previous section, we talked about side, 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 and side, angle, side. These two are just two other ways that we can prove that they are congruent by only showing 3 corresponding parts congruent in triangles. So angle, side, angle, congruence. This says if 2 corresponding angles are congruent, and their included corresponding sides are congruent, then the two triangles are congruent. So here's our little diagram depicting this. So here if I have 2 triangles, ABC and XYZ. If I have angle A and angle X congruent, angle B and angle Y congruent, and then the included corresponding sides. So here, the key here is it has to be included. So it's a side that falls in between the 2 angles. So here angle A and angle B. So it'd have to be side AB and side XY. Now if this happens, then the 2 triangles are. So notice here if we do the labeling trick, this becomes angle, side, angle, angle, side, angle, and it follows the acronym around. So we can clearly see which way it's happening here. But if we have 2 triangles set up like this, we could say that they are congruent. So triangle ABC is congruent to triangle XYZ by angle, side, angle. Okay. All right, so the other way we can also prove triangle congruence is by angle, angle, side. So angle, angle, side says if 2 corresponding angles are congruent and the side not included and the corresponding side not included are congruent, then the 2 triangles are congruent. So for this one, here we can draw out our 2 triangles, ABC, XYZ. And so let's make 2 of the angles, corresponding angles congruent. So let's make A and X congruent and B and Y congruent. It just has to be a not included side that's corresponding. So here we could say BC and X and YZ are congruent. And then if we do our labeling, look here, it's angle, angle, side. Angle, angle, side. So if we had it set up like this, these 2 would be congruent. So triangle ABC would be congruent to triangle XYZ by angle, angle, side. Now I do want to show you just a slightly different diagram for this one because it can be set up in sort of the reverse. You could look at it. So if here's our ABC with angle A congruent to angle X over here and B congruent to angle Y, and there's our triangle XYZ. Now if instead of having BC and YZ congruent, if instead we had AC and XZ, this also would be angle, angle, side. If we label it angle, angle, side, it also works. AC and XZ are also a not included side. So it could be set up either of those 2 ways and it qualifies as angle, angle, side. Just make sure that you're going around the triangle in that order. So we're going to do some proofs on these. So the first proof up here, we have that BD bisects angle ABC and angle ADC. We want to prove that triangle ABD is congruent to triangle CBD. This time we'll start off by doing a flow proof. So for a flow proof, we're going to write down our given information. So BD bisects angle ABC and angle ADC. We're going to box it in and we are going to write down given. Once we've done that, we're going to go over to our diagram and mark that. So here we have a vocab word. The vocab word is bisect. So that means that this will be the next piece of information that we're going to write down is going to be using that definition of bisect. So bisect means it splits the angle equally in two parts. So if ABC is bisected, that means angle ABD is congruent to DBC. If it also bisects ADC, that means ADB has to be congruent to angle CDB. So we are going to write that information down here. So angle ABD should be congruent to angle CBD, and angle ADB is congruent to angle CDB. We're going to box it in, and underneath we just used the definition of bisect. Okay, so notice we had a vocab word in the given. Here we're using that given information, that vocab word, to write down another step. Now let's take a look at what we have. Two angles that are congruent. So whenever we have two angles that are congruent, we need to prove that any side is congruent. Doesn't matter which one, it's just any of them. So when we're looking at this diagram, we need to either prove that AB is congruent to BC, that BD is congruent to BD, or that AD is congruent to CD. Now, which of those three would be the easiest to prove? It's definitely this middle one here would be, because it's clearly equal to itself because it's reflexive. That's something we can write in its own column because it's not flowing from anything else. It's just something that we can clearly see. So here I'm going to write down that BD is congruent to BD because it's reflexive. And now we're going to take that information we just had about the two angles being congruent and the information about it being reflexive. We're going to mark that as a side, and now we can say that the two triangles are congruent because we have angle, side, angle. So we can prove prove what we're trying to prove. So triangle ABD is congruent to triangle CBD. Box that in, and the reason why, angle, side, angle. So there's our proof. This is once again the flow proof method. All right, let's do another one. Given angle TRU is congruent to angle TQS and RU is congruent to QS, we want to prove that RT is congruent to QT. So we'll do a two-column proof for this one. I'll just move this diagram up a little so we have some more room to write. So two-column means that our first column is statements, second column is reasons, and we always start off with the given. So we are going to copy down the given. So angle TRU is congruent to angle TQS, and RU is congruent to QS, given. Okay, so now let's write down that on our diagram. So TRU, so this angle is congruent to TQS, that angle. Okay. RU, which is right here, is congruent to QS. Okay. Now, whenever we're doing these proofs, we always need to show two triangles are congruent, even if what we're trying to prove does not have two triangles congruent. So that's what we're going to do first. So notice right now we have an angle and a side. Now, if we just get another angle, we can show that the two triangles are congruent. When you look at this diagram, notice we have both triangles sharing angle T. let's highlight the two triangles. There is triangle RUT. It's sharing angle T. Okay. Our other triangle is QST. And I'll put that one in a different color so you can see it the difference a little bit better. So I'll put that one there in pink. Okay. Notice they both share angle T. So that means that they both could have this angle being congruent, which means we would have an angle side situation. So that's what we're going to write down next, is that they both share angle T. So angle T is congruent to angle T. The reason why, it's reflexive. Okay. Now we have an angle side situation, so we can prove the two triangles are congruent. So triangle RUT is congruent to triangle QST by angle side. Notice that we kept the order the same. So angle R and angle Q are congruent to each other, so those are the first ones written. Okay, and then we know RU and QS are congruent to each other, so we wrote the U and the S in the second position, and then we know angle T is congruent to itself, so that's in the third position. So we always want to make sure that we are writing our triangles in the correct form. And now if these two triangles are congruent, that certainly means that their corresponding parts are. If you look at our congruency statement here, we want to show RT and QT are equal. Well, RT and QT, those are our first and our last letters of both statements, so they have to be congruent. So RT has to be congruent to QT, and the reason why is corresponding parts of congruent triangles are congruent, CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so there's another proof, and that proof was done using the two column. All right, so we'll do one more proof today, and we will do it in paragraph form. Okay, so here's our diagram and our given information and what we're trying to prove. So we're given angle E and angle K are congruent to each other. Angle DGH and angle DHG are congruent to each other, and EG is congruent to KH. We want to prove EGD is congruent to angle or triangle KHD. So I always start with your given. So given angle E is congruent to angle K, angle DGH is congruent to angle DHG, and EG is congruent to KH. And then we'll label that. So E and K are congruent. Angle DGH is congruent to DHG, and EG and KH. Now, once again, when these diagrams have a lot of stuff on it, we always want to make sure we're looking at the correct two triangles. So we're going to highlight these two triangles. So we want to show EGD and KHD are congruent. We actually have a really good start. We have an angle side right now. Okay, but somehow we need to show that we have another angle congruent. If we take a look at what's happening, we have these two angles being congruent to one another. And notice that they both form a linear pair. So that means we should be able to show that those other two angles are also congruent. So we should be able to show that EGD, angle EGD, is congruent to angle KHD. That's our goal here. So we're going to start off by illustrating the fact that those are both linear pairs. So we wrote down our given information, and then we can say angle DGH and angle EGD form a linear pair, as well as angle DHG and angle KHD. Okay, so now we have two sets of linear pairs. Now, the other thing we need to notice on here now is that we know that DGH and DHG, these are congruent to one another. Okay? Since those are congruent to one another and these both form a linear pair, that means that these two other angles have to be congruent. Now we need to just write that down. So since angle DGH is congruent to angle DHG, and they both form a linear pair, with angles EGD and angle KHD respectively, angle EGD should then be congruent to angle KHD. Okay, so there we just showed that those two angles have to be congruent, and now we have an angle side angle. Therefore, triangle EGD is congruent to triangle KHD by angle side angle. And there we proved it. Once again, you can use any of the methods you wish to use, and we did one example of each.